Hi guys, my name is Ritisha Kiran, and today I will be going over the T-SQL programming for Module 8, and I will be addressing any questions or concerns people have for the Module 8 homework that was assigned this Sunday. I will be going over how I optimized a slow-performing query for the antipsychotic medications that were given in the homework assignment and be able to demonstrate key SQL tools that we will be using for this assignment. So the main task for this assignment um, is using the mental health meds.sql query that was given. We will be identifying prescriptions for 22 different medications and running an entire data range. I used Azure Data to do this, and we will also be using dbo.clean table to go over and sort the different medications. So we will be looking across four different columns, which I have listed here. Local drug name with dose, which will be with the different types of Rx output and the DBO.local drug and dim.local drug, which goes with the pharmacy order lab item and national drug name with dose. So we're focusing on four large text-based columns where drug information is stored and they're spread across different tables, which are listed here. The current challenge with this assignment is that the existing code uses repeated med filters across each column, and these approaches force full table scans on every row for every term, which leads to server crashes when applied to the full data set, and it causes millions of columns being created and a big computational load. And basically, our goal for this assignment is to optimize this by rethinking how we can restructure the query by reducing the computational load through smarter pattern matching and the better use of indexes and overall cleaner design without changing the original data that is given for the query set. The first term that I like to go over is compute moving average. So basically, a moving average is a rolling calculation taken over a defined number of time periods. And it's especially useful because it smooths out short-term fluctuations and helps highlight the overall trend. Um, we use this while calculating blood pressure trends, lab results, and medication usage over time in patients. This graph above shows different blood pressure results over three different types of periods, and using the moving average can help us identify this. This will help our task for the project by grouping prescriptions by month and patient, by counting how many prescriptions were filled each month, and it calculates a 3-month moving average to show smooth trends. It will overall help us visualize long-term prescribing patterns without getting distracted by sharp spikes or random drops in month-to-month data. So over here, I have a list of ideas on how we can fix the large query with some optimization strategies. In order to speed up the mental health meds.sql query, we can apply a few key strategies to improve its performance and avoid system crashes. First, we can add indexes to high impact search columns like local drug name with dose. This helps the database retrieve results much faster without scanning every single row. So adding this big database can really help search each column individually. We also replace the long list of repeated I and term conditions with a cleaner format using an array. This is an example of array with one of the columns that we use, and this really speeds up things without having to list every single thing and pass all 22 medication names in one efficient filter. To make it better, we even store the list of medications in either a temporary table or a CTE, which is a common table expression, which lets the database process them more efficiently during the joiner search. Another important change is that we avoided using wildcards at the beginning of search terms. So instead of using a percent, we can use just like quotations with the percent when possible. And this allows the indexes we created to actually work. Finally, you can use more specific where filters to early on in the query to limit how much data is scanned, making the entire process faster. So for here, this example here uses a where before the local drug name with dose, and it includes an array function. So this would be an example of a way to optimize the data. This slide shows what the original query looked like when trying to identify a prescription. It's using repeated terms throughout for every medication. This is done across 4 different columns when we're searching for 22 medications. This shows that it has to run 88 separate string comparisons. And because of that wildcard beginning of each term, it can't use indexes. This is what is causing it to slow down and show that there's no support. And the query is slow and crashes when it is running out of full set data. This shows exactly what not to do when we're trying to optimize the data for our task. So I just wanted to go over some of the parts of the second part of the homework. So this is for patient filters and diagnosis analysts. We will be using dbo.clean. Above is my image of the different columns that I have in dbo.clean, and I just selected the top 100 to make sure I have the numbers listed. So for question A, it says find all patients which have numbers 1, 2, and 3 and their IDs, and number 1 should not be in the first place. So I decided to select from dbo.clean where ID is like 1, 2, 3, and at the bottom I said ID not like 1. So this shows to find all the digits that contain 1, 2, and 3. And the ID not like filters out any patients that have 1 in the first numerical place of the data. So that's what I did for part A. For part B, I have observing the data, the first diabetes diagnosis, since we don't have the actual group. I was able to group it by patients of the age decade of when they were diagnosed with diabetes, since we don't have the actual group of the patients. And I did it right here, and I divided by 10. Age at first EM divided by 10, multiplied it as age a decade from the patient count. And for C, it asks for find patients with at least 250 admissions where each diagnosis counts for an admission. This is what I use in order to be able to find that. And I make sure having count 250 gives us patient with 250 or more diagnosis. So that way we're able to find at least 250. So this is just some of the sample codes that I have for parts A to C. For part D, which is the case control analysis, so the first part asked me to randomly split patients into a training set, 80% into a testing set, using new ID to ensure reproducibility and prevent bias. So right here, I used patient splits, distinct ID, and I was able to cast it. And I did 100% less than 80, then train. We also want to make sure that the test case patients are excluding from the training set in order to avoid any leaks in the data. And I was able to use string AAG to view patients' complete diagnostic history in one row. Okay. For part 3, we use Postgres SQL, and I wanted to go over some different commands and ways that we can work through this problem here. I'm just going to pull up the question really quickly. Okay. So for problem 3, it's asking to replace cross-apply in Postgres using arrays and subqueries. Cross-apply is basically not functional and PostgreSQL. So I'm going to be showing you guys other ways that we can attempt section 3 of the question. So we are basically given a table with an ID, which is a unique identifier for each record that contains 7 different blood pressure readings and test scores. And we're supposed to write a query that returns the ID along with the maximum value across blood pressure 1 to blood pressure 7 columns for each row. So a cross apply is basically like a joint like operator that lets you run a query for each row of a table, and it uses columns from the main table inside the subquery. And it basically helps you unpivot multiple columns in a row, and you can easily calculate the maximum, minimum, average, median. So the alternative that I've decided to use for this part of the assignment is creating an array. We can use commands like greatest for quick comparison of rows and unist for arrays for row by row logic. This helps us find the maximum values across BC1 to BC7 for each row. And the bottom is an example of me using an array, which checks a column, and I'm able to pick the highest value between the blood pressure values that are given. The second strategy I would like to use is selecting min or max values by using pivoting. This allows me to find the minimum or maximum values across multiple columns in the same row, and it is very useful when I'm able to analyze event timing or comparing multiple clinical values. So here I give an example of using dbo.clean by trying to find the earliest event age to the latest event age. The greatest returns the largest value and the least returns the smallest value. And overall, we can use this by finding the most extreme value across a patient's vital or test results, like the highest blood pressure between the two columns. So basically an array, like I like to go over, it lets you group multiple values into a single column, like a list of things. In this image below, it have a list of different names given, and we're using unist, which takes an array and breaks it into separate rows for us and helps us spread out the list if things are all like together. So right here, I'm doing select array and I list all of them out as readings from the table. And a subquery is basically a query stated inside another query, which helps breaks the code into steps to return back row-wise if we want to reverse it. So my final solution for this assignment would be to first turn all of the columns into an array for each row, then use the command unist to spread those values into rows, one per value. Then we can go ahead and group by ID and use max to find the highest value per row. This overall will help us find the biggest value from the list using the max function, keeps the values grouped by patient ID, and overall helps us find the highest blood pressure reading without using cross apply. And using this, I was able to make arrays and find the answer in Postgres. And I believe that this is probably the easiest way if you're using the UNIS method in an array, it can easily give you those values into rows. And you can find the maximum value and the least value. Thank you guys for listening, and comment down any questions or concerns for any problems in Module A, and I'm happy to answer them in the discussion.